Okay, live now.
So, welcome to our Postgres talk, Postgres Open Talks, Postgres TV series. And today we are together with Nikolay, and that's not quite a traditional thing because we do not have an invited speaker. Today's speaker is Nikolay himself.
I invited myself, right?
Yeah, but it would be interesting, and I will try to ask some awkward questions, of course, because we have today a very peculiar topic. Because generally, everyone says that we need test-driven development. Last 20 years, people trying to write tests for everything, but in our database bubble, it is always something too complicated, and we do not do a lot of testing, especially when it is about logic in the database and so on and so on. So today's topic would be how to do testing properly if you are working with database in a modern way with continuous integration, continuous delivery, and it's like sort of Nikolay's favorite topic. So he would be explaining how to do that in proper way, and I would be like teasing him and asking awkward questions. Why it doesn't work? Does it work overall, etc., etc. But as usual, we have a chat. I will try to monitor the chat and to put the questions you ask live. And well, let's go. Do you have something to add about the topic?
Right. Thank you so much. Indeed, this is one of my favorite and the topics of my interest. And first of all, I would like to thank all who joined live. We usually have only few people joining the live and many hundreds watching recording. I understand why, because it's convenient to watch later when it's convenient, and being able to put
while you're jogging, yeah.
Right. Yeah. Sometimes it's you just watch, you're just listening, not watching. It makes sense, and you can replay something or put it on pause. It makes sense, but still, like I still believe we need some online communication, and it's like also entertaining and helpful. So I encourage next time all those who are watching this recording, please try to join our open talks. We have very big plans. Full August we already booked. Every week we will have a new interesting guest already, and already is partially September booked. So I'm excited to have very good, interesting talks, and I encourage everyone to join. Also, we have already 1,000 subscribers. Big news, and 200 during last week. It's like it's great. So one tweet in Twitter added a lot. So thanks. And I also encourage everyone who is watching this without subscription, please subscribe. And please share the links to interesting materials in your social networks and groups where you discuss databases, development, Postgres, and other technical stuff. Oh, good. So let's probably start with my talk. I will try to make it short. However, like originally we think like it's not a good idea to put some restrictions for duration. Like we allow our guests to talk as long as they want to, because we can do it. But I will try this time. Can you see my screen?
Yeah, it works.
Good. I think I will. Yep, I will try to do slideshow, and you still see it, right?
Yeah, it is.
Oh.
No, just in the moment it's like black one.
Mm-hmm. Yeah.
It says loading. Yeah, now it works.
Great. So a few words about myself, since I usually like don't discuss it here on this Postgres TV channel. I'm using Postgres like 17, 18 years or so, and I used it in all my projects since 2005, and I had developed several social network, social media projects with some success, some good success. We had multi-million audience for each of them, and Postgres was always in the core, so it was a very important component of all systems I developed. I also was briefly a hacker, and very long ago I helped develop XML data type and functions in Postgres. And now my company, Postgres AI, I need to have a disclosure here. The materials I will discuss, it's also, of course, a part of what we do at Postgres AI. And this is also how we help other companies to improve their development processes. But I will try to focus on principles and allow people to not, our core technology is open source, but of course it's possible to do it without our technology. So I will try to focus on principles, especially because this area, I think it's only start, and I see new players in this area, and I'm happy they are appearing and also starting to focus on this topic. I mean, automation of database testing and CI/CD. So our company, the core product it's Database Lab. And as I've said, Database Lab engine is open source, and you can use it to implement some things we will discuss today. What it does, it provides you thin clones or database branches. There's difference between thin clones and database branches, but to understand the difference, like I'm also in the process of understanding. Some people mix these concepts, but I promise to make it clear by pgconf.eu in Berlin in October, because I have a talk there, database branching. So we will discuss the difference there. But in this talk, let's consider them as the same thing. So thin clones, database branches, for example, you have 10 terabytes database, typical example, and you can have only one machine with one volume, one 10 terabytes disk space. But on this machine, you can run dozens of independent databases and provide them to your developers or CI/CD pipelines and scale your development process, because it becomes possible to change schema and not only test changes logically, but also check performance. And this is very important. And there are some users listed here who already use Database Lab engine. And this is a couple of memes, because they illustrate the problem. Optimization of queries in production. Why we do this? Because usually, like, query plan depends on the data you have and on the settings. More precisely, not on the data, but on statistics you have and settings. So if your non-production staging, QA, anything, development environment has much less bytes, much less rows, the plan can be different. So it makes impossible, it makes the idea of query optimization on lower environments impossible, or you need to make them bigger. And then if you have if you have just one staging and multiple DBAs, for example, they can start to compete for this resource. It becomes valuable resource, single staging. So you try to optimize and someone else tries to optimize, and you start to have conflicts. And that's why usually people end up checking queries right on production and also testing indexes, right? So I'm collecting memes around this, and usually they are popular on Twitter, these memes. So, but what we can do? We can improve our testing, and we can say we want automation for testing because our project grows a lot. We have a growing team, so we have bottlenecks in terms of checking various changes and query optimization. Goals listed here. Let's speed up. I only want to highlight a couple of things. To achieve good performance, usually people think, okay, we will do benchmark meaning that we will we will take one or few same machines for full size, like the same number of CPUs, memory as production, and we will use, for example, a PG bench or sys bench or I don't know, JMeter, anything, to use all cores and like have full-fledged benchmark, load testing, and see behavior of Postgres. It's good, but this traditional approach is too heavy, too expensive, too long, not convenient for testing of small changes developers do every day. And this is the key idea of my talk today. I will try to prove it. So we should not think only about PG bench. We should think about something else. I will show you what. And change management. Also, change management, I didn't realize it a few years ago, but now I see it clearly that change management it's not only DDL, and I will also show what else. By the way, Ilya, if you see some questions in chat, feel free to interrupt me as usual. Like I'm
yeah, we have some suggestions in chat, but not exactly questions. Then it comes to questions, I will ask you. Yeah.
Thanks. Okay. Good. So, disclosure, the disclaimer or disclosure, I'm mixing these terms. This talk is more about development and less about infrastructure changes, like less about Postgres reconfiguration or upgrades or anything like hardware. It's more about the needs developers have every day, especially those who aim to have very frequent releases, frequent deployments, like a couple of times per week or even per day. So because like I see bigger challenge there, bigger problems there, and we shifted as a company, we shifted from automation of configuration testing, like let's find proper Postgres settings. We shifted to helping developers to write better queries and to avoid mistakes, for example, long-lasting exclusive lock on a table that would not detected during testing, or like some pure query which we didn't understand that it's bad in terms of performance before deployment. These two basic cases we aim to solve. And this picture, like I'm constantly updating it. This is my view on the landscape of database testing, what we can do. I'm changing it, and right now I feel it's outdated again, but I still like, let's discuss what's possible, what we have. For example, we can do some static analysis. For example, we can check schema that is going to be deployed, final schema or changes of schema, and say, oh, you are going to use primary key integer 4. It's a bad idea because table can grow to 2 billion plus rows, and we will have out of capacity in terms of integer 4. Something like this. Many things can be tested. For example, lack of primary keys and so on. You can also have data test statically, like you can check and understand that data, for example, if you take a clone of production, you can check or test it right on production. Maybe not a good idea, but still we're just discussing possibilities. You can check and see that, you know, like we are breaking, like you cannot put foreign key here because data will not allow you. So this is test of data. Static means you don't do dynamic in terms of application code. So nothing like let's insert something and so on. You just analyze data statically. Then you can perform application change management, and usually all tools are focused on DDL, like Flyway, Sketch, and so on, but they don't focus on DML. But some DDL requires DML. DDL means alter, create commands. DML is data manipulation language, like insert, update, select, delete. And sometimes you need, for your DDL, you need to update, for example, 1 billion rows, and you need to do it in batches. So DML should be also considered always, but I see tools like this capability. Unfortunately, I see a big opportunity for tools like Flyway or Sketch or Liquibase or embedded to Ruby on Rails or Django and so on. So, and now dynamic analysis. What we can do with dynamic analysis? We can run PGBench benchmark, or we can just connect to database and perform like explain, analyze buffers and see the behavior of single query. And from single query, I switched my mind some time ago to single user, single connection experiments. So you might have multiple queries, but you want to execute them sequentially using one connection. And this is key idea I will show you very soon. But multi-user experiments also make sense. For example, you want to upgrade Postgres, you have a lot of queries, you replay those queries, and you see the difference between Postgres 12, for example, and 14, and compare and present results and see what will degrade, what will improve, and so on. And there are many other things usual infrastructure teams are doing. For example, they can check how file system behaves, how new CPU behaves. They can check corruption, test backups, and so on. So you see a mix of performance-related and non-performance-related things here. But I want to say why I think this picture is already outdated, because now I see that single-user experiments and application change management, they have something in common, and we will explore this. And on this picture, to the top, it's more about application tests. To the bottom, it's more about infrastructure-related tests. So let's proceed. From testing from CI/CD, we want it fast. We want it to be cheap. We want it to be predictable, so reproducible. So if we test it again, the same results or very close results. And it also means that metrics we use should be the same all the time. So if we retest it under the same conditions, the result in terms of metrics should be the same. And that's why timing may be not a good metric if we consider bringing performance testing to CI/CD, because of two reasons. Timing is always different. If you test same query twice, you have deviation, right? So if you need to talk about timing, you need to test it like 4 times at least, and then take average. Or also, usually, because of two first reasons, we tend to do this testing in shared environments, and timing can be very different compared to production. That's why like timing probably it's not a good idea. That's why we try to find different metrics which will be the same each time we test under the same conditions. And the fact that they use testing in shared environment will not be a problem for us. So timing probably not a good metric. But fast and cheap, you know this principle triangle in project management: choose 2 or 3, fast, cheap, and good, right? And usually, like we can create another machine which will cost us a lot, same like production machine, but it will be the same, so it's good in terms of testing. But it also be slow, so it's not fast, it's not cheap, but it's good. And my statement that using new technologies, we can achieve all 3. We can have fast, cheap, and also good in terms of metrics and results. Useful results, so we can make proper conclusions. Is this change okay to deploy, or it's problematic and we need to improve? So I think we can achieve all 3: cheap, fast, and good. Okay, and so I distinguish single user experiments and multi-user experiments, multi-session experiments. Since when I started to distinguish them, the picture became clearer, more clear for me. For example, single user experiment, you can use single session connection, so you're far from saturation of CPU. If someone else is using the same machine, it's okay. But if you perform multi-user experiment, usually you tend to utilize all the CPUs, so you should be alone on this machine. And if you run PGBench in usual form, not like limiting connections, you probably will, by default, you will saturate CPU, because usually PGBench benchmarks, by the way, this is, I think, mistake, but it's another topic. They tend to perform stress testing, so like checking saturation level. But if you limit TPS, for example, transactions per second, you still tend to use multiple connections and utilize many cores. So it's not a good idea for two DBAs working with one machine. So you should be alone on this machine. But still, they are needed, right? And like focus means metrics. We can, instead of timing, we can just focus on plans. What plans we have for queries? For example, do we have plans that have sequential scans or something, and also buffers. This topic we discussed lately a lot. Michael Christofidis from pgmastered.com wrote a recent blog. Go check out that blog post. I also some time ago on Postgres AI blog, I also wrote about it. So when you analyze the one query execution plan, you should put buffers in explain analyze and see how many buffers are used there. Once you start focusing on buffers during optimization, this metric is the same every time you redo your test, especially if you start from the same point. If we thin clones, I will show it's really so. So you start from the same data, same settings, so buffers will be the same. But of course, final goal of optimization remains to timing, because users need good timing. Here we focus on multi-use experiments, pgbench, sysbench, and so on. We focus on latency and throughput, traditional two metrics for these like macro experiments, and we check utilization, saturation, and so on. So, and also, like as I've said, it's okay to run multiple single-use experiments on the same machine, so in shared environment, but it's not okay to run multiple experiments at the same time on single machine. You will have different latency and throughput, so wrong results. So you should be alone on the machine. But also, what's interesting, we don't upgrade Postgres every day. We don't upgrade the operational system every day. We don't change Postgres settings every day, usually. So these tests are not needed every day. They're not needed frequently. It's quite rarely, like several times per quarter, because it's more about infrastructure changes. So these multi-session testing benchmarks, they are needed mostly for infrastructure teams. They're heavy, expensive, long, but they are not frequent. But in today, development is crazy. Sometimes you have dozens of pull requests per week or merge requests per week, even maybe hundreds in larger projects. And it's crazy. You need, like, some people have multiple deployments per day, CI/CD, like everything is automated. So developers need testing every day. They need to be like, it should be very fast, cheap, and reliable. That's why single user experiments in shared environments, it's a key answer to testing. But let's briefly discuss multi-user experiments very briefly. This is probably another talk, but we can structure the process of that database, multi-user database experiment. We can define the input, output, and when we define it, we understand what to do to make this process also like scalable. If you have more members in your infrastructure teams, more DBAs, DBREs, we can start collecting artifacts, build some library of experiments, and so on. Like I have in my slides, I have very discussion about how to produce, like, workload is creation of workload for benchmarks. It's the most challenging part of benchmarks and multi-user experiments. I discuss it here, but I will skip it. If you're interested, I will publish, of course, publish my slide deck. And I also provide some recipes here, various tools, what you can do to run both multi-user and single-user experiments. So there are many more options than listed here, but if you don't know where to start, probably there are links here, so you can use my slide deck and start clicking on various tools later and understand how to build good workflow for multi-user experiments. But focus today is single-user experiments and like why it's important. First of all, what do you already have? You probably have one of these, maybe not listed here, but you probably have so-called database schema versioning. So you put every change to Git in form of DDL, like alter statement or create statement, or maybe if you are using some ORM, it's like some abstraction of SQL, but in the end of the day, it will be DDL anyway. And there are many tools, some popular tools are here. And the obvious thing, what do you have, like ask yourself, what do you have in CI/CD for database testing right now? If you can, maybe you can answer in chat. I will check it. It will be helpful. So probably you just have the testing of DDLs with so-called database migrations on some empty database or some small database, like fixtures involved or something, and that's it, right? So you test the forward step, like do or up, or how it's called in your tool. So you change the DL itself, and maybe you also test undo and do again. This is better actually. So on small database, so you test that logically our change can be applied to our current schema. By the way, the question is like how to ensure that we are testing in CI/CD against a real current schema, because sometimes CI/CD pipeline thinks we have one schema, but production already deviated because of some manual change, for example. It's quite common. So you need to have some feedback loop. And putting like structure SQL in Ruby on Rails to Git, it's not an answer, because this structure SQL created on development environment, but again, production might have different schema. So probably you, from time to time, you need to compare, or you just from time to time need to take your schema from production to be able to test on empty database and CI/CD pipeline reliably. So you probably check it logically. So our alters can be applied to schema. If you have undo step, it's good. So you are prepared to revert your change if something goes wrong. You test it as well, and probably do once again to ensure that like it's a idempotent task. Do undo bring us to the same point. That's why do undo do is a good idea. What else? I think that's it. If I'm wrong, please correct me, because very rarely I see something else. But I'm sure it's not enough. Why it's not enough? Because changes tested against small database or empty database, this is just a logical test. And you can easily have issues when you deploy it on large database. For example, you didn't understand that refresh materialized view on large data. You have small database in testing, but large database in production. So refresh materialized view without concurrently or create index without concurrently, or some other changes. There are many changes that can be dangerous. You can easily overlook them, and when you deploy, you put your website or app down, at least partially. It's not good. Or you produce so big workload that it's canceled because of some timeouts and so on. So you need to test it in a realistic way. And observing how various organizations are growing, I've noticed that usually we start with this basic thing, like we have tests of changes logical on small database. Then we start building some DBAs, bringing some DBAs to review our database migrations. So if pull request or merge request is marked that it's having some database changes, database migration, a review from DBA team, database team is needed from DBAs, from experts. But this is not reliable, because experts can be on vacations or they can be tired and so on. And when an experienced DBA looks at changes, most often experienced DBA say, "Oh, this is dangerous." But I was in that those shoes, and sometimes you're not sure, and you want to take and test it and see what happens, and only then provide a useful feedback and say, oh, you know, this change is really dangerous. So we are not sure, even if we have very big experience, and this is a problem. So manual review process is good, but it's not enough. And then we start thinking, oh, we want to test it for real, for big tables. We want to collect artifacts and make conclusions based on data, not based on our guess and experience. But it's not it. It's not only it. If we zoom into this, like, okay, so almost all have this, right? Almost all do it automatically, test automatically changes in CI. Some have review process, so they already had incidents on production, so they understood that DBAs should, or database experts, not always DBAs, people who understand the behavior of large databases under load, we can call them application DBAs. The term which many use, like Haki Benito also, excellent posts, he uses it in his posts. So we can talk about, okay, we need to bring people, and only some do it, not all, unfortunately. But usually management, and when management understands the problem, this is the goal, like, let's have good review process. But those people cannot review it well only checking the DDL or the code. Real testing is needed, artifacts, metrics, and so on, plans. So we start thinking about this. But if we can zoom into it and see that first we want realistic testing, and I like thin clones is the answer because it's cheap and fast. We already discussed it. I will discuss a little bit later what thin cloning is. But we also can think not only about testing DDL, but also what if our DDL will affect queries which we don't consider here in our change. For example, we created 10 more indexes for some table, and some updates which are not visible in this merge request can degrade. That's why we want also performance regression testing, regression control. We want to get 100 or 200 most important query groups from PG-style statements and ensure that there is no regression before and after. They behave the same or not worse before and versus after our change. But also interesting thing that our change, application change, code change, can bring new queries which even not present on production, and this is the most tricky part of everything. So these queries are absolutely new. DBA cannot see them on production infrastructure DBA because it's a new feature. For example, new column and some queries using this column, or even new table. So we lack data, and we want to test it, right? So, and this is probably the most challenging thing, but we want it. And I said almost no one has it, and extremely few have this. Basically, those who already started to use thin clones, and for example, GitLab is using, they have 100% coverage for all database migrations tested in CI/CD pipelines. So again, diff, it's okay, but it's straightforward. We want to test diff performance-wise, but often DML is forgotten. DML is also needed. By the way, I mentioned GitLab. You can check there what they have. They already have DML tested. So if billion rows need to be updated, batch sampling is applied, and some batches are already tested. It's cool. Like, it's an absolutely cool feature. I haven't, like, I don't know who else has it. So go check out. It's really cool. So both things are addressed, and 100% coverage is really should be the goal. And you can collect artifacts. I will show you examples. Then regression control. So we control most important queries, and we are ensure that our change doesn't matter how a developer changes the code. And developers, like, interesting point, developers usually don't change a lot of code unless this is some refactoring, right? They usually change part of it. This is also a sign that some light testing is needed. We don't need to apply full-fledged clones and like PGBench and so on, like hours of testing and so on. Since the change is small, some like okay, new column created, some new queries appeared, we want testing to be very light. But since there are examples when our change affects some other functionality, some other queries, we would like to control most important queries and to see that there is no regression. And thin clones and CI/CD, it's possible. And feature queries, as I said, it's the most challenging part. How to extract queries which are new, and also how to find proper parameters and proper examples of queries and test them. Here, it's very new topic. And I think if you're like, for example, a student right now, it's a good PhD thesis. A lot of interesting questions here. So if you're interested, you can connect to me and we will talk. It's a good topic for research. Important question. Okay, we want better testing in CI/CD, but how to copy data? How to make it testing realistic? One of ideas, of course, we can use HyperPG. There are several other things, extensions. For example, there is some extension that allows you to copy, to dump and then load statistics from production database and pretend that we have the same raw numbers and same statistic data points like on production, although we don't have this data. It's an interesting idea, but like we didn't go this path because it's like it's very interesting path, but there was decision that we won't go there, although our chatbot provides HyperPG and so on. It's sometimes like it requires a lot of development and source needs to be adjusted. And like, for example, many of these things are not supported on managed Postgres, so it's not available everywhere. But our goal was to find solution which is ready to use for everyone. You can have logical thick copies. For example, you can dump restore. It will take a lot of time, especially if you have a lot of indexes, because all indexes will need to be recreated. You can use thick clones in regular DBase style, I would say. So either PG-based backup to another machine, or restore from backups, copy somehow over network, and so on. Obviously, not cheap and not fast, right? But this is the way to go for multi-user experiments. For CI/CD, okay, possible, but it's not fun because for 1 terabyte you will probably wait at least 1 hour. If your database 10 terabytes, you will need to wait at least 10 hours on modern software. Sometimes slightly faster, but still, I've heard about 4 terabytes per hour. But it's like it's very good speed, but still, it's not something you want to have in CI/CD and developers waiting for every change to be tested. Cloud clones, it's a great thing, but for example, in AWS, EBS volume clones, they get data in approach. It's called lazy load. So data pretends to be there already, but it's still stored on S3 and loaded in background. So it's very slow again, and it takes time, like also a few minutes to create such clone. For EBS volumes, as I know, you can mark up to 50, I think, per region or something. Snapshots to be available for very fast restoration. So not from S3, but somewhere else from EBS system, like somehow it's good. But RDS, which is built on EBS, of course, disks, RDS clones doesn't support it. So every RDS clone, you first of all, you need to wait a few minutes, and then you need to warm it up to make queries fast, because data lazy load, it's still loaded from S3. So, and also an important point, you will need to pay for each RDS clone separately. So if you need to have 10 testing processes at the same time, you need 10 clones. So it's not cheap. Thin clones provided by cloud native DB. This is interesting. And Aurora, for example, it has thin cloning natively. But again, like storage is the same, but for each clone, as I understand, I'm not a big expert in Aurora, but as I understand, you need to pay for each clone separately for compute. Neon, new player, it's like open source Aurora. I'm excited that they appeared and also started to look at database branching topic and testing and how to make testing better. So great. As I understand, they are in a little bit better position than Aurora because they can, as I understand, I may be wrong, they can run multiple clones on the same virtual machine. So user will pay just once for dozens of clones. If this will be so, it will the goal to have both fast, cheap, and good, it can be achieved on Neo. And also some people I've noticed use like, okay, we have 100 gigabytes database, we can put it to Docker inside Docker, not just mount, but inside, and then git pull these 100 megabytes, and then we can run multiple clones using copy on write provided by overlayFS that Docker is using or other container system is using. It's good, but it's copy on write on file level, and Postgres stores files, shrinking it to a huge table is shrinked to 1 gigabyte file. So if you change even 1 byte in some row, copy on write will need to copy 1 gigabyte. It can be not very fast. So, but it's something that can be used as well. And then ideas of thin clones. So copy and write provided by ZFS, LVM, or something else, like B3FS or something. But we chose ZFS because we are excited how it's developed right now. It's quite fast and features and so on. So here, this tool, Database Lab Engine, developed by our team, it allows you to use thin clones for any database, RDS, managed by yourselves, and so on. So anything, and this is great. Like I will show you some examples of what can be achieved. This is like the core component that allows you to achieve proper performance testing in CI/CD for database. And possible future we discussed with some folks lately, like it would, like in Database Lab Engine, each clone, even we pay for one single VM, but each clone is running Postgres in separate container. And what if Postgres itself, Postgres can provide you, and some people, I didn't list it here, but some people do it. You have some database, you can say create database, new database, and use the other database as template. This is thick cloning inside one Postgres server. All directory will be copied. Good. It's slow, of course, if database is big, but it's good because it gives you like SQL level control over cloning. And we discussed it would be so good if Postgres understood that like there is a copy and write capability inside, like for example, provided by ZFS or something else. So directory shouldn't be copied in a regular way, but instead it can be copied virtually. So like I have picture here. All shared data blocks remain the same. We don't copy the same blocks. We don't multiply. Like since development changes only part of whole thing, we don't need everything to be copied and be fully independent physically. We can keep a lot of blocks the same. And if create database command would understand, for example, like thin clone option, it would be very fast for database of any size and would be very good for development. But this feature is not yet developed. It's like a nice idea, which probably someday will be developed. Database Lab Engine already fully developed. We do it for more than 2 years and a lot of features inside. So important thing is that we are moving from one database copy and 10 persons on or 10 CI/CD pipelines working with it. It's not a good idea because they are conflicting. We are moving to idea that each person has their own database copy. or each CI/CD pipeline have their own database copy. And this changes a lot the whole thing. Like, this is exactly why we can achieve both good, fast, and cheap. So, and this makes DevOps process, if we are in DBA shoes, we usually think, oh, dev is quite weak because we cannot test many things there. So that's why we go to production to test many things. DBA goes to production to check indexes and so on. So this is how I see, if I'm DBA, I look at DevOps infinite cycle as dev is smaller than ops in terms of capabilities. And if you start doing thin cloning, for example, with database lab engine, it's already balanced. So dev becomes powerful, and you can do a lot of very good things and make your testing powerful in CI/CD pipelines. And this is what's also called shift-left testing, because it brings testing closer to developer. So ideally, developers should be able to test everything, not disturbing others, not asking for help and waiting for days from DBA, not disturbing others in terms of resource utilization. So I will take this database and test, don't touch it. And when, I mean, DBA is still needed, but when DBA looks at the problem, basic questions already solved, basic metrics already collected, and real help already happening, not simple things like, oh, let's check how it will work. So developers should have power to test. And interesting point that developers are those who influence on queries because they create queries. They either directly writing them or indirectly through or RM. But very often they don't have access to production. They cannot test queries, and this is a big problem. So that's why it's worth, like, shift-left testing should be applied to databases. And like, I will probably skip this. This is an internal infrastructure of database lab engine. As I've said, we run each Postgres in separate controller. Important thing, in container. So if you want 10 clones, you need 10 containers. Important thing here, limiting factor, is memory, because Postgres needs to allocate like, for example, the buffer pool size shared buffers is 1 GB. We need to allocate this amount of memory. And if you have, for example, 10 GB, you cannot create more than 10 clones, each having 1 GB, but you can reduce shared buffers. And interesting thing is that we can reduce shared buffers. It will affect timing, but it won't affect the plans and planner behavior, because planner doesn't look at shared buffers in Postgres. Planner looks at effective cache size. So we can set effective cache size to the same level as production has. And this is an important trick we use, right? This is like one of secret sauces. We use the same level of effective cache size. So planner thinks we have this memory, but we don't. Usually we have much less memory and very small shared buffers. But since we tuned planner settings in proper way, we have the same plan as on production. And this is workflow, like database lab engine copies database once. Sometimes if it's logical copy, dump restore from RDS, for example, it does it periodically. For example, full refresh every Saturday, or maybe every day. It depends on the situation. And then if it's physical level, restoring from backups, for example, like WAL-G backup restore. It's also possible to tune database lab engine that it replaces walls, so it becomes virtually a standby of specialized standby of the source of production. And on schedule, it creates snapshots, and developers can use snapshots to create clones in seconds. This is the main trick here. And clones are fully independent, so you can do anything, alter, update, drop everything. Others won't notice it. And clone is destroyed automatically by that database lab engine if it's not used. This feature was developed long ago. And this is like we call it like ephemeral databases or compose. How to call it? Like you can throw it out, like very temporary databases, but they are full size. You see like 10 terabytes database when you connect to it. Magic. But so one disk, dozens of databases. There are many things like security and so on. But let me show you related, like security is a big topic. Some people tend to remove PII and not have it. Some people consider database lab engine in this mode as part of production. So it's like realistic testing, similar to Canary deployments or blue-green deployments. So we like final testing before we deploy it. Of course, it's good if you can afford to keep the data the same, because any change you do it in database, might affect plans. So let me show you some examples. This is for GitHub. For example, this is very simple example. We have a create index without word concurrently and database lab engine. It has a component called the database migration observer. It checks every few seconds, it checks what exclusive logs we have. And if we have long exclusive logs, we mark this migration as not possible for deployment, very dangerous, testing fails. So we block this deployment. It protects us from deploying such things. Additionally, in our system, Postgres CI console, additional artifacts can be uploaded. We develop improved version right now, which will also post a comment to pull requests or merge requests with summary. You can check, since it's open source, you can check in Database Lab Engine repository on GitLab. So we have a lot of artifacts, and like we can say a lot about migration. For example, we can download full Postgres log and so on. Of course, like something is visible to developer right on GitHub, but there is also a question here. Even if the database contains PII, it should be isolated from the world, and we solved this problem. So no network connections to the world, and all artifacts which are present on GitHub, they don't have PII. It's possible to keep some artifacts uploaded to Postgres CI having PII, and you can control access. For example, people with production access can see them. People who, like developers who don't have production access, see only summary and data without PII. But it's a big question to have this isolation, like separation of access levels. So like this is example, a case study from GitLab. You can read it here. Some links. For example, it was done some time ago, like maybe more than 1 year. So at that time, main database was 14 terabytes and cloning was 15 seconds. Dozens of clones were running at the same time. As I've said, they implemented very good testing, 100% coverage for all database migrations. And this is example of one of the first cases when this worked. It was one of co-founder Dmitry Zaporozhets made some test, and database lab engine caught some dangerous change. It was very good. It was more than 1 year ago. So many things can be analyzed and presented to expertise. For example, DBA can, when developer brings attention and needs review, instead of checking only DDL and trying to guess what will happen on production, when database expert such as DBA checks it, a lot of artifacts already collected. So it's easier to say, oh, dangerous logs, or some, I don't know, like wall generation rates will be insane, and so on. So many things can be checked by DBA. This is why it's so good. Let's skip this. So, but diff is not enough. As I've said, we have 2 more ideas: regression control test in terms of performance, so other queries won't be disturbed if we do this change. And also this most tricky thing, performance test of new queries. I call it feature. So idea is that we see if you write tests, if a developer writes tests, we can extract queries from tests, which were executed against small database. But then we need to apply these queries to realistic clone, probably clone as is of production. And this is what is not yet developed, but I think it will be developed eventually by our team and others as well. So we want, this is like the cutting edge of database testing in CI/CD pipelines. How to, like, if you consider development branch, you can see diff on GitHub or GitLab in terms of code. You can see diff in terms of schema, but how to see diff in terms of workload, SQL queries, what new queries will appear, how existing queries will be adjusted. This is the quick question which performance test on new queries and regression tests try to answer in terms of performance. And interesting that for regression tests, we can apply the same methods as for benchmarks. So we can extract examples of queries from logs, especially if you're using auto-explain, or we can analyze PGStar statements and try to craft workload. The same can be applied here, and this is what we do. But we will do only single connection, so testing will be possible in shared environment. So CI/CD pipelines are able to test these like 100 of most important queries and say if there will be regression after deployment. But this is the most challenging thing. Like, it's still like we're still discussing how to do it properly. If you're interested, please talk to me. We will discuss. I would love to talk in details. So, of course, thin cloning is bad for stress testing because you're not alone with it on this machine, and probably other people also produce some workload. So it's not a good idea. And testing related to infrastructure, such as upgrades and so on, and also to testing for backups and so on and so on. So thin testing is more for application development. Very often, cheap, fast, and good. I repeat this, and the three key takeaways here. First, let's distinguish multi-session, multi-user experiments, so-called benchmarks, more from infrastructure teams. And let's distinguish load testing for particular things where we can use single connection and run just one query or a few queries sequentially. This can be done in shared environments. This can be done using thin cloning. Next, if you can consider full-size databases in CI/CD, it becomes possible. I might not see some other people work. I'm constantly researching, but I'm still maybe missing. Please, if you know some similar work, bring it to me. I would love to read about other people's work as well. Of course, there are systems like Delphix, Actifio, which do this for years, but it's not like they are enterprise, cost a lot. Consider Database Lab Engine because it's open source, and you can do it right now for your Postgres databases. Again, maybe some people do something. I would love to talk with those people and like discuss how to bring all of us in terms of engineering community to better future where database testing is better. And finally, when you do performance testing in shared environments, in non-production, on different hardware, probably something different, less memory and so on, focus on execution plans and buffers, not on timing. This is like one of the key things I learned over the last years. Without it, everything, like anyone can say, oh, you cannot do it because hardware is different. No, we can do it, and we should do it because we want our tests to be cheap and fast and good, right? So that's why buffers are also important. That's actually it. This is our Slack and Twitter. Please join. Do you have any questions?
So far we don't.
Okay.
In the chat.
Everything is clear.
Yeah, it's too clear and a lot of information actually. So basically, I think many people would intend to just digest this information first.
And ask questions in comments. We will
Yeah.
monitor it 100%.
Yeah, as we do usually. I have actually a small question. So,
Sure.
am I correct that currently this product is actually very dependent on OpenZFS as a technology?
Yeah, so we have an option to use LVM, but
Yeah,
it has,
that was my second question. So, did you consider to use all
it's
them?
possible, but it provides less features, fewer features. Because, for example, when you create a clone on LVM, it's always the last point. Well, it's still possible to use it, but usually, like, since we anyway need to create another machine, it's possible, for example, to go to AWS Marketplace and with few clicks create it. And ZFS, since it's more powerful, has more features. For example, it provides compression as well, implicitly, so transparently. And for development environments, people tend to make costs lower, so compression is good. It's just easier and for us, and like, but LVM is also an option. You can adjust configuration and say I want LVM to be used. Some features will be not working in some cases, but possible, and we still maintain it. So it's still maintained. Also, this engine, it's written in Go, and it's very modular. And for example, if you want B3FS or something else to be used for to provide thin cloning capabilities, you can just develop it because it will be just a module, and you can create merge request. We will review, approve it. It will be good contribution. It would be good contribution.
Yeah.
Mm-hmm. Yeah. So great. Yeah, good. If there are no more questions, I guess that's it. I as usual, I ask.
Yeah, put your questions into the comments.
Yeah, into the comments or connect over Twitter, write me email or something, go to our Slack, ask questions there. As usual, I ask everyone to, again, of course, like, subscribe is important, and also share links in your social networks and working groups where you discuss databases and engineering. Thank you so much. Till next week.
Thank you.
Bye.